Well, hello everybody and welcome to our flipped classroom here. Hope you had a great time over the summer, but now it's time to get real and serious as we start our calculus year. Our topic today, you'll find yourself with a nice easy topic called finding limits graphically. And I just want to remind you of our game day. We're always going to focus on this date, is our May 6th big game day exam. Before we dive right in, I came across this picture here and I just had to show it to you. Now, a lot of you probably think, he looks young, perhaps he's coloring and he's this excited, but we all know that's not the truth. There ain't nothing in the world he'd be doing than calculus to have that expression on his face. So how excited are you to get started? Alright, so before we dive right in, let's just talk about what a limit is. So our definition in our notebook here is as a function gets closer and closer to a certain x value, what is the graph's intended height? And that's what we're saying to ourselves over and over when we look at these pictures. What is the intended height? What are the intentions of the graph? So before we actually dive into a problem, we do have to not only be able to do the math, but speak the math correctly. So again, just take the time. You can pause and stick these in your notebook, but I do want you to make sure you understand how this is read. This is a left-handed limit. Notice that negative sign above the C. So this is read, you start on the left here, the limit as x approaches c from the left of f of x. Okay, and let's write that notation off to the side. The limit as x approaches c from the left of f of x. Very similarly, a right-handed limit is going to have that plus sign. The limit as x approaches c from the right side of f of x. And then, of course, we have just the general limit. The limit as x approaches c of f of x. So when they don't say left and right, that implies to you that you have to check both the right and the left. Now, I need you to take your time and carefully sketch this picture in your notebook. All of our questions are going to be off this one picture, so again, take your time. I've tried to plot the points as accurately as I could there for you to follow, but pause it and let's get a great sketch in your notebook, probably a half a page long. So now that we have that sketched, I know everybody is familiar with limits graphically, but again, we're going to slow down, we're going to take a nice start to the year, and we're going to practice this one more time. So I've got 3 questions down here for you. The first one says, the limit as x approaches 0 from the left of f of x. Okay, so the first thing I go is I look for x and 0. I go to the x-axis, I find my 0, which I'm going to say is right here. Okay, now I have to approach x from the left-hand side. Well, if this is 0, this is the left-hand side, so I'm looking at this piece of the graph. Now, does this graph or does this graph get closer to 0? Hopefully it's pretty obvious. This graph never goes towards 0, but this one certainly does. So if I follow this graph as I get towards 0, what is the intended height? What would you say this graph is reaching a height of? Well, I would say as I look here on the left, it's reaching a height of 4. And that's all we're looking for. Very similarly, let's do the same thing for the right-hand side. The limit as x approaches 0 from the right-hand side of f of x. So I'm going to do the same thing. I'm going to take my pointer. I'm going to find my 0. Here it is. The right side would be this half of the graph. Now this one goes that way. That doesn't go towards 0. That one stays there. But this one, if I follow, will come towards 0. So as I follow this curve and I'm approaching 0, I want to get towards 0. The intended height is 4 again. Therefore, I can say the general limit is 4. So again, it's the same picture. You don't have to regraph it. You've got it in your notebook once. Let's try a few more. The limit as x approaches 4 from the left of f of x. So I'm going to find 4, and notice it's the x approaches 4, so I'm finding 4 on the x-axis. So here's my 4. I need to come in from the left-hand side, so this is the left of 4. Anybody over here? Now again, this is the graph that's actually going to get to 4, so I'm going to use this graph. As I follow this graph and head towards 4, approach 4, where is the intended height? I would definitely say it reaches an intended height of 0. Now, does it actually ever reach 0? No, but that's okay. We don't care about that. The intended height. And that's why I want to stress that word intended. It's intending to reach a height of 0. All right, let's follow 4 in from the right-hand side. So here's 4. As I come in from the right-hand side, well, that one's not going to come in. This one's going to come in from the right-hand side. Okay, this is the only function on the right-hand side. It's intending to reach a height of -4. Now, what would I say the limit is as x approaches 4? Well, I would say that limit does not exist. Now, you might be thinking, why does it not exist? Let me remind you the definition of a limit. Okay, for a limit to exist, and again, let's get this in our notebook, the limit as x approaches a from the left side of f of x has to equal the limit as x approaches a from the right side of f of x. Okay, I need my left-hand side to equal my right-hand side for the limit to exist. So in our previous example, they were the same value, the limit existed, and it was whatever that number was. In this example, the left side and the right side don't meet, so our limit does not exist. Alright, so again, using that same picture, why don't you pause it and grab the answer to these three questions. What is the limit as x approaches negative 2 from the left side of f of x? What is the limit as x approaches 2 from the right side? And then what is the limit as x approaches 2 of f of x? So again, pause it, see if you get the same answers. So real quickly, here's my negative 2. As I come in on the left, my intended height is positive 2. As I come in from the right, my intended height is positive 2. Therefore, the left side equals the right side, the limit exists, and the limit is 2. Remember, the left has to equal the right. Now, just for fun, what if I said, what is f of negative 2? What would you say that answer is? If you went right to negative 2, and you wanted to know what is the exact height at negative 2, hopefully you would say, when I go to negative 2, the actual height is sitting at 1. Okay. Now again, that didn't have anything to do with limits, it's just a nice refresher question. What if I said, what is f of 4? Look at that graph, evaluate f of 4. So I find 4. Now would you say it's 0? Would you say it's negative 1? Would you say it's negative 4? Could it be all three? Well, think about this. To be a function, of course, this guy has to pass the vertical line test. If I drew a vertical line here and they were all closed dots, it would not pass. That's why 2 of them are open and 1 of them is closed. So the only point that I actually count is where it exists, where it's closed, and I would say f of negative 4 is negative 1. Alright, well hopefully you've got the idea down. I've got 4 more for you to practice. Again, pause it, see what you get, then hit, play again and see if they match with mine. Alright, so as I find 6 on the x-axis, of course that's where I'm starting. Oops. As x approaches 6 from the left, that's this guy, it looks like it has a height of negative 4, or it's intending to. As I come in on 6 on the right, its height is negative 5. So I've got negative 4, negative 5. The limit from the left does not equal the limit from the right, therefore the limit does not exist. You can write it like that, or a little DNE. Does not exist. And what is f of 6? Well, remember, it can't be both points. Pick the point where you actually see a point, which is the closed point, so I would say negative 5. Alright, the limit as x approaches negative 4 from the left. So, if I find negative 4 and I come in from the left, where would you say this graph is intending to go? I would say its intentions go down forever, which implies negative infinity. If I come in at 4 from the right, again, its intentions are going down forever, which is negative infinity. Now here's the big check. Alright, put this in your notebook, this is huge. Is infinity an actual height you can count to? Can you count to infinity? Well, heck no. Now, here's the catch. Even though the left side equals the right side, infinity is not actually a number you can count to. So in this case, the limit does not exist. Okay, even though your left and right were the same values, it's not an actual value you can count to. So the limit does not exist. Be careful with that one. Infinity is not an actual number. Now, what is f of negative 4? Well, do you see any solid points there? No, so again, this value does not exist. Alright, let's go ahead and get a new sketch in our notebook. A quarter of a page would be perfect for this one. Let's make it nice and neat. And we're just going to ask 2 questions about this. So pause it if you need to, come back. What is the limit as f of x approaches infinity? Now, this one's very simple as well. Basically, you're going to go to the x-axis and you're going to walk towards infinity. So, let me get my pointer. Here's my x-axis, of course. As I walk towards positive infinity, what is the intended height of the graph? Well, certainly I'm not looking at these graphs here. This is the only one that goes out towards positive infinity. How high is this graph always going to reach? What's your estimation there? I would say a height of 1. And you'll notice you have a horizontal asymptote. When a function approaches infinity, you should be getting a horizontal asymptote. Let's try the same thing with negative infinity. Just take yourself out to the x-axis and head towards negative infinity. Okay, what is the intended height of the graph? So again, this graph doesn't matter, this piece doesn't matter. As you walk towards negative infinity, looks like the intended height is going to reach a height of 0. Okay, again, you can kind of see it, teetering off there, so we've got a nice little asymptote in there. So when you see x approaching infinity, you should be thinking horizontal asymptote. Alright, well I've got one final problem for us tonight. So if you found the first problems very simple and easy, hopefully this will be a little more thought-provoking for you, maybe put a little pep in your step if you know what I mean. And I'm going to try to walk you through these as nicely as I can. So our goal here is, given 6 criteria, we need to graph a sketch based off the given criteria. Now, in theory, all our graphs could look a little different, slightly different, but we should have some, common characteristics amongst our graphs. So I'm going to start with criteria A. It says the limit as x approaches 2 from the left has an intended height of 3. So here's what I do. I find the x-axis, I approach 2, find my 2 here. I know I'm going to have a height of 3. Now I'm going to put an open circle there because I don't know at the moment if I'm open or closed, so it's always best to put an open circle there. The other thing I'm going to do is, notice it was as x approaches 2 from the left. I'm going to put a little tail on the left-hand side to remind myself I'm coming in from the left side. Now, I kind of wrote these in a goofy order. I'm going to go over to D next, and I'm going to say the limit as x approaches 2 from the right has an intended height of 1. So I'm going to go back to my 2. I know at 2 I should have an intended height of 1, so again, I'm going to put an open circle there. I might come back to fill one of them in. I don't know yet. I'm going to tail it off on the right side this time. Okay. Now, again, we might fill those in. Let's look at the next criteria. F of 2 is 6. Well, that's huge. That tells me at 2, my close point is 6. So that's implying that I'm going to leave this one at 3 and this one at 1 open. Remember, I can't have both of these closed. It would not be a function and pass that vertical line test. Alright, I'm going to go to E next. Sorry, I kind of did these in a goofy order. The limit as x approaches negative 3 from the left side of f of x is going towards infinity, positive infinity. So think about this. In order for your graph to go up towards infinity, what has to be here? Hopefully you're saying a vertical asymptote. If your answer is going to infinity, you have to have a vertical asymptote. So I'm going to find my x-axis at negative 3 and put in my vertical asymptote. Now we know that when I come in from the left side, it says I'm going towards infinity. So I'm not going to draw a complete graph, but I am going to show from the left side I'm going towards positive infinity. Likewise in C here, as x approaches negative 3 from the right side of f of x, I'm heading towards negative infinity. So again, if my graph wants to go down, there's got to be an asymptote. If I'm equaling infinity or negative infinity, I have an asymptote. So I'm going to kind of sketch this in on this side of the neighborhood down south here, showing that I'm heading towards negative infinity. Alright, now this time, notice x is approaching infinity, so that was my horizontal asymptote that we talked about last time, of f of x equals 5. So I'm going to draw in that horizontal asymptote at 5. And now I'm ready to, put my whole picture together. So here's what I can do, and remember, they should look similar. They should have these same characteristics, and where I go from there can look different on every page. I'm going to start with this guy. I don't know anything else on this side of the graph here, so all I'm going to do is continue this graph, maybe come down a little. Okay, the only thing you need to do is go from end to end. I'm going to go to this guy, and I know I have to approach this tail here, so I'm going to connect those two. And then this one, our limit has to approach 5. As I go towards infinity, I have to get to an intended height of 5. So I'm going to curl that one up like that. And there you have it. So again, we took some liberties drawing those in. Just make sure we're on the correct sides here. And we should be in fairly good shape. I do want to make one note here. This tends to scare some people sometimes. You are allowed to crash horizontal asymptotes. Okay, that was a big pre-calculus idea. You are allowed to crash them. We'll talk a lot more about that this year. That is okay, but you cannot crash vertical asymptotes. So if you have any major questions, feel free to find me in the morning or during one of your study halls, and have a great night. We'll see you tomorrow.